The theory of continental drift, first proposed by Alfred Wegener in 1912, initially faced heavy skepticism from the scientific community. At the time, the idea that continents were not stationary, and had once been connected in a supercontinent known as Pangaea seemed highly implausible. Scientists were dubious because there was no clear mechanism explaining how continents could drift across the Earth's surface. Wegener's hypothesis lacked the technological backing and scientific understanding needed to convince the majority of researchers. It was a radical and unconventional idea that seemed too far-fetched for the established scientific views of the early 20th century. As a result, many geologists and other experts rejected the notion outright, labeling it as an eccentric, unsupported theory. However, as time passed and more research was conducted, the idea of continental drift gained new life in the 1960s. During this period, scientists began to gather significant evidence that challenged traditional beliefs about the Earth's geology. The advent of new technologies, like seismographs and ocean floor mapping, revealed previously unknown aspects of the Earth's structure. In particular, the discovery of mid-ocean ridges and the pattern of magnetic striping on the ocean floors offered crucial clues about the movement of continents. These findings provided compelling evidence that the ocean floors were spreading and that tectonic plates were shifting, causing the continents to drift apart over millions of years. With these new observations, scientists started to rethink the concept of continental drift and began to see the validity of Wegener's ideas. By the time the 1960s rolled around, the scientific community had gathered enough evidence to seriously reconsider the theory. The concept of plate tectonics, which included the movement of Earth's lithospheric plates and their interactions at plate boundaries, began to take shape. As more data was collected, it became clear that the Earth's surface was not a static, unchanging structure, but rather a dynamic and ever-changing one. This marked a monumental shift in geological thought. The idea that the continents had once been part of a single landmass, which slowly drifted apart, was no longer considered a wild speculation, but a well-supported theory. It took about 50 years for continental drift to evolve from a fringe idea to an accepted scientific theory. What had once been dismissed as a curious hypothesis eventually became a cornerstone of modern geology. Scientists now had a comprehensive framework, plate tectonics, that not only explained the movement of continents but also provided insight into many geological phenomena such as earthquakes, volcanic eruptions, and mountain formation. The acceptance of continental drift and the development of plate tectonics was a pivotal moment in the history of Earth sciences, reshaping our understanding of how the planet works and its geological evolution.